All right, this next video is going to focus on ionic substances. We haven't talked about what is an ion yet, so let's go ahead and do that first. An ion, this phrase or term ion, refers to an electrically charged particle obtained from an atom or chemically bonded group of atoms as a result of adding or removing electrons. You can't really add or remove protons without changing the identity of the element. So if you want to change the charge, the only way to do that is to either add electrons or remove electrons. So there are two kinds of ions or categories of ions. An anion is a negatively charged ion. And the way I remember that is anion kind of sounds like onions. Onions make you cry. Crying is kind of negative. So I remember anions are negatively charged. They're typically nonmetals. Nonmetals usually carry that or like to carry that negative charge. We'll explain why in a later chapter, but for now you just kind of have to memorize that nonmetals carry that negative charge. So things like O2 minus, Cl minus, N3 minus, and F minus, these are all negative charges. What that charge is tells you how many has been lost or gained. So for example, O2 minus means that it has gained 2 electrons because electrons are negatively charged. So the more electrons you gain, the more negative you become. Again, electrons are negatively charged. So the more electrons you gain, the more negative charge you have. So O2 minus is an oxygen atom that was neutral but gained 2 electrons, okay? N3 minus is a neutral nitrogen that has gained 3 electrons. We'll talk more about how to count overall electrons and protons in just a second. Cations are the other subcategory of ions. Cations are all positively charged. Okay, and again, how would you remember that? Cats have paws, right? Paws, so they are positively charged. And again, cations are usually metals, and so examples are Na plus, Ca2 plus, Fe3 plus. Okay, and it is really counterintuitive because when something is positively charged, they've actually lost electrons. But again, it makes sense because electrons are negatively charged. So if you lose negative charge, you will become positive. I repeat again, if you lose electrons, you lose negatively charged particles, you will become positive, right? So here, if you have, say, for example, calcium 2 plus, that really means you have lost 2 electrons, right? So really important to catch the phrase gained and lost in these two categories of ions. When an anion and a cation come together, then it forms an ionic compound. And it has to be composed of cation, positive charge, and anion, negative charge, so that they balance one another and the overall charge on the ionic compound is often neutral. A great example is table salt. Table salt is NaCl. Why is NaCl going to come together? It is because Na is positive 1, Cl is minus 1. Let's kind of zoom in a little bit just to understand what is happening with NaCl. Na, if you look on your periodic table, is in box number 11. So it has an atomic number of 11. So by definition, it has 11 protons. If you look at this picture here, this has 11 protons, right? But on the outside, there are actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. So you've seen here that this is not a neutral species, right? 11 protons, 11 positive charges, right? And 10 negative charges, 11 plus, 10 minus. If you add them together, you are going to get 1 plus, right? So this ion is 1 plus. So here, sodium is plus 1. Notice the protons and electrons are not the same like the neutral atoms. These are charged species, so the protons and electron numbers cannot be the same. Chlorine has 17 protons. And again, we know that because the atomic number of chlorine is 17. Chlorine is in box number 17 on your periodic table. And again, if you count the number of electrons on the outside of this figure, you will notice that it has 18 electrons. So again, if you have 17 plus and 18 minus, if you add them up, you're going to end up with 1 minus, right? So that's why Cl is minus. Okay, so really, when these two ions come together, the cation, which is your sodium, positively charged, and your anion, which is your chlorine minus, it will form sodium chloride, which overall is neutral because sodium plus, Cl minus, and chlorine minus together will form a neutral species. So, in a general term, we should be able to look at a periodic table, okay, and just be able to predict what is the charge. Metals lose electrons equal to their group number and become positively charged ions, okay? So really, some of the metals that are known and always the same is group 1 is always 1 plus. So every one of these, when it's in an ionic compound, is going to be 1 plus. Group 2 is going to be 2 plus. Every one of these is going to be 2 plus when in an ionic compound. I want to emphasize when in an ionic compound. When hydrogen, for example, is not in an ionic compound and by itself, it is not 1 plus. Only when it is with and in an ionic compound with a negative charge. All right, silver is always 1 plus, zinc and cadmium are always 2 plus, and aluminum is always 3 plus. The other ones that we've shaded with purple and covered up with purple, they are also often, sometimes, positively charged, but their charges are not always 1 plus, 2 plus, 3 plus, 4 plus, etc. So we're going to talk about those in a later video. But for now, I would pause the video and write 1 plus over group 1, 2 plus over group 2, 1 plus next to silver, 2 plus next to zinc and cadmium, and then 3 plus next to aluminum. The nonmetals like to gain electrons. As a result of gaining electrons, which are negatively charged, they will have the same number of groups as they are from the nearest noble gas. So for example, if N and P will be 3 minus, right? Because it's 3 away from the noble gas. Oxygen, sulfur, and selenium will be 2 minus, and fluorine will be 1 minus. Noble gases usually don't make any ionic compounds, so we put a 0 there. I again would pause the video and write -3, -2, and -1 over these groups, these particular groups as well. Main group elements lose and gain electrons to obtain noble gas configuration. And we'll talk a little bit about what exactly is a noble gas configuration at a later stage. So for now, I would pause the video and write 1 plus, 2 plus, 1 plus, 2 plus, 3 plus, -3, -2, -1 accordingly. Now, how are we going to use that information to be able to do some problems? Okay, I just want to say one more thing I forgot. I just want to make sure I go back and cover that. When we are looking at the AZ notation, we said the A was the mass, right? So we said here this was the mass, and Z was the atomic number or the number of protons. The charge is usually written in the top right-hand corner, so as a superscript in the top right-hand corner. It's just a way we write notation. All right, so how will we write the AZ notation for something with, say, 8 protons, 8 neutrons, and 10 electrons, right? So we want to know what is the A, or the mass, what is the Z, or the atomic number, and then we would like to know what is the charge, right? To be able to fill out the AZ notation. Of course, we also need a symbol, right? So let's first look. 8 protons will tell us what? 8 protons will tell us Z, or the atomic number. So we look in box number 8. 8 is here. Let's zoom in here. 8 is here, right? So it is oxygen, right? And so the atomic number is going to be 8, right? It's going to be oxygen. Okay, the mass is equal to the protons plus the neutrons, so that's going to be 8 plus 8, or 16, right? So we can already start to fill out some things, right? We're going to say 16, 8, oxygen, right? Because this is your A, this is your Z, right? What's the charge? And this is a new thing that we learned. The charge is going to be the result of your protons and electrons. So let's go ahead and do some math. You've got 8 protons plus 8. You've got 10 electrons minus 10. That's going to give you 2 minus, or minus 2. So your charge is going to be 2 minus. Okay? Let's look at another problem here. You've got 12 protons, and again, that'll tell you the box number, the Z. So let's go ahead and look in box number 12. Box number 12 is magnesium, okay? So here we have the atomic number Z is 12, okay? The mass, again, is equal to protons plus neutrons. So that's going to be 12 plus 13, or 25. So again, we can start to fill things out, right? We can say, hey, the 25 should be where the A is. The 12 is the Z. And we know it is magnesium, or Mg. Last but not least, we've got to figure out the charge. We have 12 protons, so plus 12. We have 10 electrons, so minus 10. So we end up with 2 plus, right? So the magnesium is 2 plus, okay? So that gets us the charge, right? The charge is always the result of adding the protons and the electrons together to figure out the charge. So hopefully that kind of helps you with figuring out charge, okay? The other kind of problem that you could be presented with is something like this, where you have 19 protons, 20 neutrons, 18 electrons. What is the charge? Again, it's quite simple. You've got 19 protons, you've got 18 electrons, minus 18. So really, at the end of the day, you're going to have 1 plus, right? Because 19 minus 18 is 1, positive 1. Okay. So hopefully this kind of helps you to figure out when you're looking at the subatomic particles, what is your A, what is your Z, and then what is your charge. So I'm going to circle these answers here. Okay, and you can pause the video and go ahead, or stop the video, and then go ahead and do this next table. See if you can fill it out based on the information that we've already talked about, and then the next video will tell you the answers to this problem.